Okay, in this video, we're going to be doing polar, parametric, vector, multiple choice question practice for the AP Calculus exam. This is all Unit 9 of Calc BC. This is part 4 of 8 in theory. 1, 2, and 3 are definitely done and up. I don't know, I'm kind of running out of steam here working on these, but eventually the other 4 parts will certainly exist. So let's get started. So question 37, it's a calculator question for time t greater than or equal to 0. The velocity of a particle moving in the xy plane is given by t to the 5th, comma, quantity 1 plus radical t squared. At time t equals 1, the position is 4, 3. What is the distance between the position of the particle at 1 and the position of the particle at 2? So this is basically a distance formula problem. And the distance formula here, I'm going to choose to write as the magnitude of, I'm calling the position r of 2 minus r of 1. So I want the magnitude or the norm of r of 2 minus r of 1. I also need to know how to figure out r of 2. So r of 2, by the fundamental theorem, I know the velocity, so I'm just going to say it's r of 2 is r of 1 plus the integral from 1 to 2 of v of t dt. So we're given v of t, we need to find r of 2 and then the distance between where you are at 1 and where you are at 2. So I'm going to do this 2 different ways on the calculator. So here's one way of doing it. I define v of t, and then I do where I start, which is 4, 3, plus the integral from 1 to 2. So basically plus the displacement, 1 to 2 v of t, which gives me this. And then I find the norm of the difference between the starting vector and the ending vector. So this is one approach. That's certainly how I would do it. But if you're not as familiar with that, or you don't like that, or whatever, here's another way that I would choose to do it. Figure out where you are at 2. So for x, it's 4 plus the integral from 1 to 2 of t to the 5th. For y, it's 3 plus the integral from 1 to 2 of that thing. And then just do the distance formula between the point 4, 3 and the point 14.5, comma 7.938. And either way you do it, you get 11.603, which is option A. All right, next up. If x of t, if x is t squared minus 1 and y is the natural log of t, what is the second derivative of y with respect to x in terms of t? So second derivative of y with respect to x, this is a formula that you just have to know. I mean, you can also work it out, but you really need to know. This should be a priority formula because it comes up, when it comes up, you don't want to mess it up because it's actually pretty straightforward. But if you don't have it memorized, you're probably going to mess it up on the exam. All right, so the second derivative of y with respect to x is the derivative of dy dx with respect to t. So the derivative with respect to t of dy dx over dx dt. So we need to find dy dx. I like to start with y prime because you're going to do the first thing divided by the second thing. Your brain is going to tell you to do that. So derivative of natural log is 1 over t. The derivative of t squared minus 1 is just 2t. So dy dx is going to be green over blue. So if you've watched all the videos and done all the problems, you've heard me say the same things over and over. And if you keep watching, if I keep making the videos, I'm going to keep saying them because it's the same things over and over. That's how you achieve success on this exam. Just do as many problems as you can, and eventually they all look the same. So dy dx is 1 over 2t squared. It's better maybe to write that as 1 over 2 times t to the negative second. Whatever. All right, we need to find our second derivative, so we're just plugging into the formula. The derivative of 1/2 t to the negative second with respect to t is negative t to the negative third. So bring the negative 2 down, subtract 1, and then divide by 2t, which is dx dt. Simplify that, we get negative 1 over 2t to the 4th, which is option A. All right, so let's look at 39. Calculator question again. Position of an object moving along a path in the xy plane is given by the parametric equations x of t, which is 5 sine of pi t, and y of t, which is the quantity 2t minus 1 squared. We want the speed of the particle. So speed is the magnitude of velocity, which is true whether you're doing parametric or you're just doing motion along a line, like a Calc AB type problem. So speed, magnitude of velocity vector is the square root of dx dt squared plus dy dt squared. So 2 different ways we could do this. It's a calculator problem. I could define r of t, which is the position vector, and then find the norm, the magnitude, of the derivative of position or velocity at t equals 0, and that gives me 16.209. If you don't like that, I get the sense from my students that most of them choose to do it this second way. find the derivative of x at 0, find the derivative of y at 0, and then find the magnitude of that, or the square root of dx dt squared plus dy dt squared. Either way, we're getting the same answer. Doesn't make a difference. Nobody will even know because it's multiple choice. All right. The length of the path described by the parametric equations, x is cosine cubed of t and y is sine cubed of t between 0 and pi over 2 is given by what? All right, so arc length, length of a path, distance traveled for parametric or vector valued functions, all the same thing. Arc length is the integral from a to b of the magnitude of velocity, or the speed, square root of dx dt squared plus dy dt squared. Let's just find these things. So I need dx dt and I need dy dt. Both of them involve the chain rule. One of them is better. 3 cosine squared, the derivative of cosine is negative sine. So this I'm going to kind of rewrite a little bit. Dy dt is going to be 3 sine squared, the derivative of sine is cosine. So this one we don't need to rewrite, which is why I think it's better, but whatever. Now we're just going to plug in, and we've got to square them, so I'm not going to make you watch that. When I square these, I get 9 cosine to the 4th sine squared plus, when I square the second one, I get 9 sine to the 4th cosine squared. There's stuff you can do to that, but they don't do it. They're not really big on trig identities on the AP exam. You just look at the answer choices. If what you have is there, pick it. If not, start thinking about sine squared plus cosine squared is 1 and things you can do with that. But again, they're not really big on that anymore. They used to feature it a little more. All right, new problem. Which of the following expressions gives the total area enclosed by the polar curve r equals sine squared of theta shown in the figure above? So off the top of my head, like I do know what this looks like, but like not really. I mean, so I got to figure this out. So I'm going to look at the rectangular graph of r equals sine squared of theta, which again, I don't really know what that looks like, but maybe I don't totally need to. So if I'm just thinking of sine, right? Like if I were just graphing sine, because I'm basically taking a sine graph and then just squaring its y values. So since I know what sine looks like between 0 and pi, I basically know what sine squared looks like. It's going to do this, right? So this is from 0 to pi. That's that top half of the graph. That's all we need. So that's this. So if I just go from 0 to pi, and also look at the answer choices, every one of them goes from 0 to pi. So like obviously this is a thing. So I could find this, but then I'm going to need 2 of them because that's only half of it. So I'll do 2 of the area of that, which will be 1/2 the integral from 0 to pi, and then the function, which is sine squared, and that should give me what I need. So this simplifies to 0 to pi sine to the 4th. We don't actually have to do it, thankfully, because that would be super annoying. This looks like option D. All right. So again, looking at the rectangular graph is probably the number one way of finding polar areas, which seems maybe a contradiction. I don't know. Let's look at another one. Which of the following integrals represents the area enclosed by the smaller loop of the graph of r equals 1 plus 2 sine theta? I'm going to do this without even creating the polar graph. I'm just going to think of the connections between rectangular graphs and polar graphs. So I'm going to really graph the rectangular function. So it's a sine curve, so 2 pi, and then pi over 2 and 3 pi over 2. It has a sinusoidal axis of 1 and an amplitude of 2. So you go 1 up to 3, down to -1. And then it's positive sine, so it's intercept, maximum, intercept, and so on. Okay, so sketch this. Now, where is the inner loop? The inner loop is that little bit below the axis. It's where the radius goes negative. So knowing how to graph polar from rectangular is extremely useful because that means you just need the rectangular graph. That's my inner loop. I have a lot of videos on graphing polar. If you're unfamiliar with this concept, I recommend you spend a couple minutes getting a little familiar with it at least, because it makes all the polar problems so much easier. I need to know those intercepts though. So 1 plus 2 sine of theta is 0. So sine of theta is -1/2, which means theta is 7 pi over 6 and 11 pi over 6. I mean, if you look at the answer choices, all of them seem to have like some combo of like 7 pi over 6, 11 pi over 6, maybe negative pi over 6 is sort of involved in some of them. But anyway, I know the inner loop goes from 7 pi over 6 to 11 pi over 6 now. So if I were just writing this, it'd be 1/2 the integral from 7 pi over 6 to 11 pi over 6 of the quantity r squared. And then I look at the answer choices. That's option A, so that's the answer. B, they forgot to square it. C, they're doing some weird thing. Negative pi over 6 to 7 pi over 6, like look at the rectangular graph. You're including the entire outer loop, part of the inner loop. It's very strange. Negative pi over 6 to 11 pi over 6 is even worse. 7 pi over 6 to negative pi. Like, I feel like a lot of the answer choices are just bad. And, like, either A or B was going to be the answer just based on weird options there. And so, like, and then they didn't square in B. So even if you didn't know, like, always look at the answer choices and decide, like, can they help me find the answer? Let's do another. The polar curves r equals 1 minus cosine theta and r equals 1 plus cosine theta are shown in the figure above. Which of the following expressions gives the total area of the shaded region? Okay, so we, like, have to look at the answer choices for this because, like, who really knows, right? So 0 to pi, 1 plus cosine of theta squared. Pi over 2 to pi, 1 plus cosine squared. 2 times 0 to pi over 2, 1 minus cosine theta squared. D, I'm thinking, is very unlikely to be the answer no matter what. So I would probably eliminate that right away if I, like, you know, was stuck for time. All right, I'm going to look at 1 plus cosine's rectangular graph so that I can hopefully use it to evaluate some of these answer choices. So 1 plus cosine looks like this. All right, so let's look at option A. We're going from 0 to pi. So that's this part. And then on the rectangular graph, so you're starting at positive 2, and then you're going counterclockwise. So that's going to be this part. So if I were to use that as my interval, I would get, like, way too much area, right? Like, I just got half of the entire cardioid, and I don't want that. So that can't be the answer. So A is out because of the 0 to pi, and that means that D is also out because of the 0 to pi. I was eliminating D, like, right away. So A would have given me 1 full cardioid, I guess, and I don't want that. So now the question is it B or is it C? So if I look just between pi over 2 and pi for this, pi over 2 to pi is this part. So that's definitely 1/4 of what I want. So if it's 1/4 of what I want, I would have to double that to get, like, so it's just the top half, let's say. I would get 1/4 of it. So I would get half. What am I trying to say? If I do from pi over 2 to pi, that gives me half of half, right? So I'd have to double and double. But I'm not doubling and doubling. I'm just doubling once in the answer choice to B. B is not the answer. So that can't be the answer. Let's look at C and see if we can see why that's the answer. So if I go from 0 to pi over 2 for C, that's going to, well, I mean, that's our answer. Here's our rectangular graph for this. If I go 0 to pi over 2, that gives me this. Okay, good. So I need 2 of those because this is 1/4 of what I want. So I need 2 just to get the top and the bottom part. I need to double it to get 1 of them. And then polar is 1/2 the integral. This is, like, hard to explain, but I think easier to figure out. This is what I would want. And this is going to simplify down to option C, which I've already chosen, but I felt compelled to explain why it's the answer. So there we go. Struggled, but got through it, maybe. I don't know. That's definitely the answer. Look at your answer choices, see if they can help you eliminate things. Go from there. New problem, thankfully. All right, for any time t greater than or equal to 0, if the position of a particle in the xy plane is given by x is t squared plus 1 and y is the natural log of 2t plus 3, the acceleration vector, so we have position, we're going to need to go down to the second derivative here. So acceleration is x double prime, y double prime. On a free response question, I would definitely write that before I, like, dove in and did the problem. Now I'm going to dive in and do the problem. So x prime is 2t plus, just 2t. So that makes x double prime 2. Y prime is going to be 1 over 2t plus 3 times 2. So y prime is 2 over 2t plus 3. Y double prime, so I'm thinking of that as 2 times the quantity 2t plus 3 to the negative first. So that's going to be 2 times negative 1 and then 2 from the chain rule. So negative 4 and then to the negative second. But I'll write it as negative 4 over 2t plus 3 to the second. It's just finding the derivative, so, I mean, I'm confident you know how to do that at this point, but I didn't show the work. So our acceleration vector is 2 comma negative 4 over quantity 2t plus 3 squared. So that is whatever. That's e. All right, let's take a look at another problem. Position of a particle moving the xy plane is given by the parametric equations t cubed minus 3t squared and 12t minus 3t squared. At which of the following points in the xy plane, or at which of the following points xy, is the particle at rest? All right, what does it mean to be at rest? We've encountered this before in these videos. It means that the velocity vector is 0, which in the case of vectors means the x dt and dy dt are 0. You have to consider both because there might be places where dx dt is 0 but dy dt isn't, or dy dt is 0 but dx dt isn't. Got to think about everything. So dx dt, power rule, 3t squared minus 6t, got to equal 0. I'm going to factor, set it equal to 0, and solve. So I get t is 0 and t is 2. dy dt is, by the power rule, 12 minus 6t. That equals 0. We need to solve that. That's just t equals 2. So notice, only 2 came up both times. At t equals 0, dy dt is 12. So it's like you're not moving left or right, but you are moving up. So you're not at rest. So t equals 2 is the only answer. But we need to figure out the point xy. So we're going to take 2 and plug it in for x and y. So x of 2 into this is going to be 2 cubed minus 3 times 2 squared. So 8 minus 12 is negative 4. And then for y, we do, take 2 and plug it in. So you get 12 times 2 minus 3 times 2 squared. 24 minus 12 is 12. So our ordered pair, negative 4, 12. And so we got that. All right, let's look at the next one. Particle moves in the xy plane so that its position for t greater than or equal to 0 is given by the parametric equation. X is natural log of t plus 1. So you might notice they do sometimes make x be a natural log. X or y have natural logs. That's pretty common. We've seen it in a lot of problems. So be on the lookout for that. Y is equal to kt squared, where k is a positive constant. The line tangent to the particle's path at the point where t is 3 has a slope of 8. This is kind of different. Like, they're telling you what the slope is, and they're asking for the value of k, but you just go into it with the same thought process, right? Slope for parametrics is going to be dy dt over dx dt, or dy dx is y prime over x prime. I'm going to do the thing I usually do. Find y prime first, then x prime. So y prime, by the power rule, is going to be 2kt. X prime, the derivative natural log of t plus 1 is 1 over t plus 1 times 1. So x prime is that. So dy dx is y prime over x prime. And then I need to evaluate this at 3, because we actually know that when t is 3, we get a slope of 8. So I'm going to plug in 3 here. And when I do that, I'm plugging in for t, so I get 6k over 1/4 is equal to, well, that's 24k when you simplify it. Now that has the slope, dy dx is 8. This problem has parts that it's giving you, right? The slope is 8, so 24k dy dx is equal to 8, which means that k is 1/3. So it's a little bit of a twist, but like not much. You can definitely do this. Just don't worry. When you get a problem you've never really seen before, you know the calculus. So you just have to figure out, how does the calculus that I know apply to this problem? And in this case, it was straightforward. It was just like, we haven't really seen this yet. All right, question 47. What is the slope of the line tangent to the polar curve r equals 2 cosine theta minus 1 at the point where theta equals pi? So I think there are 2 ways to do this. If you know how to graph this, pi is like a very standout value for this particular curve, which means you can probably find the slope just by looking at the graph. If you don't, you can use polar slope. So I'm going to do it in both ways and probably regret that. But I'm going to first graph r equals 2 cosine theta minus 1. So to do that, I set it up. I graph this. Here I go. I'm going to turn this into the polar curve. So I have this. I know that there are going to be tangent lines at the origin where there are zeros for the rectangular graph. So I didn't bother to find them because they're not happening at pi. They're somewhere in there. And then this part of that, so you go from positive. When theta is 0, you start positive. So start positive, go to the origin, and then you're going to keep going all the way through. So we're going to get kind of this. This is polar graphing. If you are familiar with polar graphing, this isn't really that bad. The key thing is that when you get to pi, you're at this point, and that's clearly going to have a vertical tangent line, which means the slope is going to be undefined. If you're not up on your polar graphing, I wouldn't say fine. You should definitely improve on that. But you can still answer this question because polar slope is still dy dx. X is r cosine, y is r sine, and we can just do it, right? So x is r, the polar curve, times cosine, which means dx d theta. Use the product rule, first derivative of the second plus second derivative of the first. Then plug in pi, right? So the cosine of pi is -1. The sine of pi is 0, which means everything just zeroes out. So we get 0. Y is going to be the polar curve times sine of theta. Use the product rule to find dy d theta. So we get this. Now we have to evaluate this at pi. Cosine of pi is -1. Sine is 0. So the whole second part just disappears. So you get cosine of pi is -1. So you have -2 minus 1 is -3 times -1. So overall the slope, or dy d theta I should say, is 3. So dx d theta is 0. You get 3 over 0. That's undefined. Either way you do it, you're going to get the answer. Knowing how to graph in polar is useful. I recommend it. I know it's something that not everyone is super great at going into the exam. I recommend you spend a couple minutes and try to make sure you're kind of up on the relationship between rectangular graphs and polar graphs. It's a really useful skill. All right, so 48, the last question in this. I don't know what's happening with the other 4 videos that I planned out in this, but certainly the first 4 exist and you can watch them. And 48 questions is an awful lot of questions. I think we've covered basically everything. The other videos will just be additional practice that I hope you take time to watch after I take time to make them, but who knows. All right, a curve C is defined by parametric equations. X is t squared minus 4t plus 1, y is t cubed. Which of the following is an equation of the line tangent to the graph of C at the point -3, 8. Okay, so this is our standard equation of a tangent. So dy dx is going to be dy dt over dx dt, and don't confuse x and t. As long as you don't confuse x and t, you should be fine with this, right? So I'm going to find dy dt, find dx dt, evaluate them, and find dy dx. That's my game plan. All right, so actually, we're at the point -3, 8. We don't know what t is. That's kind of an issue. Looking at the answer choices, I would guess that t is probably 2, because look at option B where they say x is equal to 2. Actually, without doing this problem now, I would think the answer is probably A, because I think that t is going to end up 2, and I think that they're trying to fool you with a vertical tangent line, and you'll pick the value of t, and you'll get it wrong, but the actual answer is just the x coordinate. I think the answer is probably A, without doing it, but I already did it, so you know that I'm kind of cheating on that, but I do think that that's what's happening, and it happens a lot. So let's figure out the t value. I'm going to use y because y only has 1 value, whereas x could have 2 potential values. So y is equal to 8, which means that t cubed is equal to 8, which means that t is equal to 2. So now t is 2. I'm going to evaluate dx dt and dy dt at 2, but first I have to find those. So dy dt first is going to be 3t squared. And if we just plug in 2, we're going to get 12. And then dx dt is going to be 2t minus 4. And if we plug in 2, we are getting 0. And so we're going to get 12 over 0. That means that dy dx is undefined. An undefined slope means a vertical tangent line, and a vertical tangent line means the equation is x equals the x coordinate, whatever it is. So our answer here is going to be x equals -3. So it was the scenario that I was saying, although I had already done the problem. I hadn't thought of that while I was doing the problem, so I get 2 perspectives on this. I write the problem and think about it. Then I do the problem so that I can run through it in the video. And then in the video, when I'm recording it, I read the problem again. It's I get it from a lot of different perspectives. I end up doing so many practice problems when I make these videos. Anyway, that's the next set of 12. We're up to 48 problems. That's a ton of practice. I think you've seen basically everything that you need, so I don't feel bad about not necessarily finishing these right now. But I hope this was helpful, and good luck.